Good afternoon, ma'am.
Hello, good afternoon, students.
Good afternoon, ma'am.
Yes, good afternoon. I hope my voice is clear.
Yes, ma'am.
Okay. So we'll begin with the class. Just 1 minute. We will start the class.
Shetty, ma'am.
So students, today we are going to start with the next topic, that is oscillations. ಆಯ್ತಾ? So ನಾವು ಇವತ್ತು oscillations ಅನ್ನ ನೋಡೋಣ. So last class ಅಲ್ಲಿ ನಾವು thermal properties, then mechanical properties of solids, fluids, ಹೌದಾ, ಇದೆಲ್ಲ ಲೆಸನ್ ಅನ್ನ ಕಂಪ್ಲೀಟ್ ಮಾಡಿದ್ವಿ. ನಾವು ಇವತ್ತು oscillations ಅನ್ನ ನೋಡೋಣ. ಸೊ ನಂದೇನ್ ಸ್ಯಾಟರ್ಡೆ ಕ್ಲಾಸ್ ಇತ್ತು ಅದ್ರ ಬದಲಾಗಿ ನಾನು ಇವತ್ತು ತಗೊಂತಾ ಇದ್ದೀನಿ. ಸ್ಯಾಟರ್ಡೆ ಸರ್ ತಗೊಂತಾರೆ, ಆಯ್ತಾ? ಸೊ ಆಸಿಲೇಷನ್ಸ್ ಅಲ್ಲಿ ನಾವು ಫಸ್ಟ್ ಪಾಯಿಂಟ್ ವಿ ಆರ್ ಡಿಸ್ಕಸಿಂಗ್, ದಟ್ ಇಸ್ ಪಿರಿಯಾಡಿಕ್ ಮೋಷನ್. ಸೊ ವಾಟ್ ಯು ಮೀನ್ ಬೈ ಪಿರಿಯಾಡಿಕ್ ಮೋಷನ್? ಸೊ ದ ಮೋಷನ್ ವಿಚ್ ರಿಪೀಟ್ಸ್ ಎಟ್ ರೆಗ್ಯುಲರ್ ಇಂಟರ್ವಲ್ಸ್ ಆಫ್ ಟೈಮ್ ಅಂತಂದ್ರೆ, ಹಿಯರ್ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ದ ರೆವಲ್ಯೂಷನ್ ಆಫ್ ದ ಅರ್ತ್ ಅರೌಂಡ್ ದ ಸನ್, ಹೌದಾ, ದ ರೆವಲ್ಯೂಷನ್ ಆಫ್ ದ ಅರ್ತ್ ಅರೌಂಡ್ ಇಟ್ ಸೆಲ್ಫ್, ಇದೆಲ್ಲ ಏನು ಪಿರಿಯಾಡಿಕ್ ಮೋಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಯಾಕೆ ಪಿರಿಯಾಡಿಕ್ ಮೋಷನ್ ಅಂತ ಇದೆ? ಬಿಕಾಸ್ ವಾಟ್ ಎವರ್ ದ ಟೈಮ್ ಇಂಟರ್ವಲ್ ಇಟ್ ಇಸ್ ಟೇಕಿಂಗ್, ದ ಟೈಮ್ ಇಂಟರ್ವಲ್ ಇಸ್ ಫಿಕ್ಸ್ಡ್ ಹಿಯರ್, ಹೌದಾ. Here whatever the time interval, at the same time interval if the motion is repeating, then it is called as what? Periodic motion, aita. Then next we have the next type of motion, that is oscillatory or vibratory motion. So what do you mean by oscillatory or vibratory motion? Yes, so based on the oscillations you will get two questions here. Okay, so I'll tell you which concept, ಯಾವ concept ಮೇಲೆ ಬರುತ್ತೆ ಅಂತ ನಾನು ನಿಮಗೆ ಹೇಳ್ತೀನಿ. So let us see the next point, that is oscillatory or vibratory motion. What do you mean by oscillatory vibratory motion? Oscillatory or vibratory motion is that motion in which a body moves to and fro or back and forth. Antandre, here you can see this example. So what is to and fro motion? That is nothing but, suppose if you consider a simple pendulum. So if it is moving in this way, so this kind of motion. So this kind of motion it is called as what? To and fro motion or back and forth motion anta heltare. So such kind of motion is called as what? Oscillatory or vibratory motion. In such a motion, the time is confined within well defined limits on either side mean position. Antandre ಇಲ್ಲಿ ಏನ್ ಟೈಮ್ ಲಿಮಿಟ್ ಇದೆ, ಸೊ ದಟ್ ಇಸ್ ಫಿಕ್ಸ್ಡ್ ಹಿಯರ್. ಮೀನ್ಸ್ ವಾಟ್ ಎವರ್ ದ ಟೈಮ್ ಇಟ್ ಇಸ್ ಟೇಕಿಂಗ್. ವಾಟ್ ಯು ಮೀನ್ ಬೈ ಮೀನ್ ಪೊಸಿಷನ್? ನೀವೇನಾದ್ರೂ ಪೆಂಡ್ಯುಲಮ್ ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, ಸೊ ದಿ ಸೆಂಟರ್ ಪೊಸಿಷನ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಮೀನ್ ಪೊಸಿಷನ್, ಆಯ್ತಾ. ಸೊ ಇಟ್ ವಿಲ್ ಮೂವ್ ಅಪ್ ಟು ಸರ್ಟನ್ ಡಿಸ್ಟೆನ್ಸ್, ದೆನ್ ಅಗೇನ್ ಇಟ್ ವಿಲ್ ಕಮ್ ಬ್ಯಾಕ್ ಟು ದ ಮೀನ್ ಪೊಸಿಷನ್, ಅಗೇನ್ ಇಟ್ ವಿಲ್ ಮೂವ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್, ಅಗೇನ್ ಇಟ್ ವಿಲ್ ಕಮ್ ಬ್ಯಾಕ್ ಟು ದ ಮೀನ್ ಪೊಸಿಷನ್. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ದ ಆಸಿಲೇಟರಿ ಆರ್ ದ ವೈಬ್ರೇಟರಿ ಮೋಷನ್. ಇದನ್ನ ನಾವು ಹಾರ್ಮೋನಿಕ್ ಮೋಷನ್ ಅಂತ ಕೂಡ ಹೇಳ್ತೀವಿ. What do you mean by harmonic motion? Harmonic motion or harmonic oscillation is that oscillation which can be expressed in terms of single harmonic function. So what is single harmonic function? Here you will ನೋಡಬಹುದು, that is nothing but either sine or cosine. ನೀವು ಇಲ್ಲಿ ನೋಡಿ ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು, that is y is equal to a sin omega t or y is equal to a cos omega t, right? So y is the displacement, a is the amplitude here, omega is angular frequency, time t is the time interval. So adana nodana yav tara equation barutte yakanta next now discuss madana. So some of the important definitions are there. That is nothing but the time period here. What do you mean by time period? It is the least interval of the time after which the periodic motion of a body repeats itself. That is called as what? Time period here. Means here it is a fixed interval of time after which the motion is repeating. So ಅದೇನ್ ಫಿಕ್ಸ್ಡ್ ಟೈಮ್ ಇಂಟರ್ವಲ್ ಏನಿರುತ್ತೆ ಅದನ್ನ ನಾವು ಟೈಮ್ ಪೀರಿಯಡ್ ಅಂತ ಹೇಳ್ತೀವಿ. Then frequency. What do you mean by frequency? It is defined as the number of periodic motions executed by the body per second. It is defined as the number of periodic motions executed by the body per second. ಅಂತಂದ್ರೆ 1 ಸೆಕೆಂಡ್ ಅಲ್ಲಿ. ಸೊ ಟೈಮ್ ಪೀರಿಯಡ್ ಅಂತಂದ್ರೆ ಒಂದು ಆಸಿಲೇಷನ್ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತೆ ಅದನ್ನ ಟೈಮ್ ಪೀರಿಯಡ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂತಂದ್ರೆ 1 ಸೆಕೆಂಡ್ ಅಲ್ಲಿ ಎಷ್ಟು ಟೈಮ್ ಆಸಿಲೇಷನ್ಸ್ ಆಗುತ್ತೆ ಅದನ್ನ ನಾವು ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂತ ಹೇಳ್ತೀವಿ. ಓಕೆ, ದೆನ್ ದ ನೆಕ್ಸ್ಟ್ ಪಾಯಿಂಟ್, that is angular frequency. So this angular frequency is denoted by the letter omega. What is angular frequency here? The angular frequency of a body executing periodic motion, it is equal to the product of the frequency of the body and the factor 2 pi. So illi mathematically now ಹೇಳ್ತಾ ಇದ್ದೀವಿ, that is angular frequency is given by 2 pi n anta ಹೇಳ್ತಾ ಇದ್ದಾರೆ. So that is angular frequency 2 pi n. Right. Then next here omega is also represented the angular velocity also. Then next the unit of angular frequency or the frequency is hertz here. Hertz is the unit here. And displacement. So what do you mean by displacement? So in general the displacement is given to a physical quantity which undergoes a change with time in a periodic motion. With time in a periodic motion. Okay. Then what do you mean by phase? Phase ಅಂತಂದ್ರೇನು? Phase of a vibrating particle at any instant physical quantity. ಅಂತಂದ್ರೆ ಈ ಬಾಡಿ ಏನಾದ್ರೂ ಆಸಿಲೇಷನ್ ಆಗ್ತಿರ್ಬೇಕಾದ್ರೆ ಅವ್ರು ಕೊಟ್ಟಿರುವಂತ ಟೈಮ್ ಅಲ್ಲಿ ಯಾವ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ಬಾಡಿ ಇದೆ, ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್? ಫೇಸ್. ಆ ಕ್ವಾಂಟಿಟಿ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? ಫೇಸ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಆಯ್ತಾ? ಸೊ ದಿಸ್ ಆಸಿಲೇಟರಿ ಮೋಷನ್ ಇಸ್ ರಿಟರ್ನ್ ವಿತ್ ದ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಎಕ್ಸ್ಪ್ರೆಷನ್, ದಟ್ ಇಸ್ y is equal to a sin theta. So theta we can substitute it as omega t plus pi naught, where theta is equal to ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು. What is pi naught here? Pi naught is the phase of the vibrating particle. ನೀವು ಇಲ್ಲಿ ಜಸ್ಟ್ ನೀವು ನೋಡ್ತಾ ಹೋಗಿ ಅಂತಂದ್ರೆ ನಿಮ್ಗೆ ಗೊತ್ತಾಗತ್ತೆ ನಂತರ ಇದನ್ನ ಯಾವ ರೀತಿ ನ್ಯೂಮರಿಕಲ್ ಅಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡ್ಬೇಕಂತ. ಆಯ್ತಾ? ಸೊ ದಿಸ್ ಇನಿಷಿಯಲ್ ಫೇಸ್ ಅಂತ ಹೇಳ್ತಾರೆ. ವಾಟ್ ಇಸ್ ಇನಿಷಿಯಲ್ ಫೇಸ್? ಕ್ವಶನ್ ಪೇಪರ್ ಅಲ್ಲಿ ಇರುತ್ತೆ ಇನಿಷಿಯಲ್ ಫೇಸ್ ಆಫ್ ದ ಬಾಡಿ ಅಂತ. ಸೊ ಆವಾಗ ನೀವ್ ಏನ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ? ಇನಿಷಿಯಲ್ ಫೇಸ್ ಅಂತ ಇದ್ರೆ t is equal to 0 ಅಂತ ನೀವು ಕನ್ಸಿಡರ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ. ಓಕೆ, ಸೊ ದಿಸ್ ಇನಿಷಿಯಲ್ ಫೇಸ್ is also called as epoch. It is also called as epoch here. Okay, then next we have the same phase. So ಯಾವಾಗ ನೀವು ಎರಡು waves ಸೇಮ್ ಫೇಸ್ ಅಲ್ಲಿ ಇದೆ ಅಂತ ಹೇಳ್ಬೋದು. Two vibrating particle are said to be in the same phase if the phase difference between them, it is an even multiple of pi. So ಯಾವಾಗ ನಾವು ಎರಡು waves ಅಥವಾ ಎರಡು particles same phase ಅಲ್ಲಿ ಇದೆ ಅಂತ ಹೇಳ್ಬೋದು when they are even multiple of pi or the path difference is the even multiple of lambda by 2. So I'll repeat here, ನೀವು ಯಾವಾಗ same phase ಅಲ್ಲಿ ಇದೆ ಅಂತ ಹೇಳ್ಬೋದು body ಅಲ್ಲಿ, that is if the phase difference is even multiple of pi or path difference is even multiple of lambda by 2. ಇದೇನಾದ್ರೂ ಕಂಡೀಷನ್ ಇದ್ರೆ ನಾವು ಅವಾಗ ಸೇಮ್ ಫೇಸ್ ಅಲ್ಲಿ ಇದೆ ಅಂತ ಹೇಳ್ಬೋದು. ಆಯ್ತಾ? ಸೊ ಇದು ಥಿಯರಿಯಲ್ಲಿ ಕೆಲವೊಂದ್ಸಲಿ ಕೇಳ್ತಾರೆ. Then opposite phase, when the two vibrating particles cross their respective mean position at the same time moving in an opposite direction. So same phase ಅಲ್ಲಿ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ? They will be in the same direction. Opposite phase, the vibrating particles will be in the opposite direction. Avaga phase difference estagutte heli? 180 degree. Yes, then next opposite phase ಕೆಲವೊಂದು values ಅನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು. That is opposite phase means the phase difference between the particle is all multiple of pi. That is pi, 3 pi. ಅಲ್ಲಿ even multiple ಬರುತ್ತೆ ನೆನಪಿಟ್ಟು. So same phase ಅಲ್ಲಿ even multiple ಬರುತ್ತೆ. ಇಲ್ಲಿ opposite phase ಅಲ್ಲಿ all ಬರುತ್ತೆ. What about the path difference? Same phase ಅಲ್ಲಿ even multiple ಬರುತ್ತೆ of lambda. ಇಲ್ಲಿ all multiples of lambda. You can see the examples. Yes. What do you mean by phase difference? If two particles performing SHM is simple harmonic motion. Next point is another. If two particles are performing simple harmonic motion and their equation are given as y1 is equal to a sin omega t plus phi 1 and y is equal to a sin omega t plus phi 2. Then what is the phase difference here? The phase difference is given by these two values. ಆಯ್ತಾ? ಈ ಚಾಪ್ಟರ್ ಅದು ಮೇನ್ ಕಾನ್ಸೆಪ್ಟ್ ಇರೋದು ಸಿಂಪಲ್ ಹಾರ್ಮೋನಿಕ್ ಮೋಷನ್ ನೋಡಿ. ಸೊ ನಮ್ಗೆ ಜಾಸ್ತಿ ಕ್ವಶನ್ಸ್ ಸಿಂಪಲ್ ಹಾರ್ಮೋನಿಕ್ ಮೋಷನ್ ಬರುತ್ತೆ. ಸೊ ಇದೇನ್ ನೋಡಿದ್ವಿ, ಇದು ಜಸ್ಟ್ ಬೇಸಿಕ್ ಫಾರ್ ಅವರ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್. So what is simple harmonic motion? The simple harmonic motion is also called as SHM. So this simple harmonic motion, it is a kind of periodic motion anta ಹೇಳ್ತೀವಿ ನಾವು. So periodic motion ಅಂದ್ರೆ ಈಗಷ್ಟೇ ನೋಡಿದ್ವಿ ಏನದು, that is a motion which repeats at regular interval of time, that is periodic motion. Then what is the difference between periodic motion and the simple harmonic motion? ಹೌದಾ? So simple harmonic motion ಅಲ್ಲಿ ಒಂದು special condition ಬರುತ್ತೆ ಏನಂತ ಅಂದ್ರೆ, that is here whatever the restoring force is there, it is always directed to the mean position, and that is directly proportional to the displacement of the particle. I'll repeat that. That is, il nodi here SHM, simple harmonic motion, it is nothing but it is periodic motion. Then what is the difference between periodic motion and the simple harmonic motion? The periodic motion, it is only repeating at regular interval of time. But in case of simple harmonic motion, we know that the body is moving to and fro. So the body conditioning there should be some force responsible for that. Adu yav force agatte? Restoring force agatte. That is nothing but the restoring force here. So this restoring force, whatever it is there, this restoring force is directly proportional to the displacement. Here you can see that after the restoring force, there is a displacement here. It is directly proportional to the displacement of the body. Here we will consider the minus sign. Yak minus tagantare antandre, the restoring force and the displacements will be in opposite direction. Here you can see here this last equation. To remove this proportionality sign, we are taking a constant, that is K here. This K is called as what? Force constant. Then what is the unit of this force constant? Now yav tara baribodu adanna? K is equal to F by X anta baribodu. What is the unit of force? Force unit en barutte? Yes, students, what is the unit of force? Yes, it is Newton. How that? Then displacement is given in terms of meters. So it is nothing but what? Newton per meter. And the dimension formula is m t raised to minus 2. So m t raised to minus 2 is the dimension formula of the force constant K. Yes. So let us go for the next one. Yes. So the simple harmonic motion, alli kelon terms anna now define ಮಾಡ್ತೀವಿ. That is nothing but the displacement, kinetic energy, potential energy, then the total energy. Adralli ನಾವು first ನೋಡ್ತಾ ಇದೀವಿ, that is displacement in simple harmonic motion. The displacement of a particle executing simple harmonic motion at an instant is given by, that is y is equal to, that is y is equal to a sin omega t plus or minus pi. A sin omega t plus or minus pi, where a is the amplitude and omega is angular frequency, t is the instantaneous time. T is instantaneous time. Then what is capital T? Nodi, small t matte capital T ge difference agutte. If it is small t, it is instantaneous time. If it is capital T, it is time period. ನೀವು ಇಲ್ಲಿ ನೆನಪಿಟ್ಕೋಬೇಕಾಗುತ್ತೆ. Then n is the frequency, pi is it is initial phase. Okay. Then here on the x-axis, the same equation can be written as, it can be given as x is equal to a cos 2 pi by t into t plus or minus pi. So already we described what is all the small t, capital T and the pi terms here. This is displacement expression. Idanna nenpidi. Then velocity in simple harmonic motion. So the velocity of the simple harmonic motion is given by, you can see the equation, that is v is equal to omega under root of a square minus y square. So what is omega here? Angular frequency. What is a? A small a is nothing but it is amplitude. Then y is the displacement. Yes. Then next we have when this velocity is maximum or when this velocity is minimum. So some conditions they have given here. That is, in simple harmonic motion, velocity is maximum at equilibrium position. So velocity maximum irutte, that is at the equilibrium position, the velocity will be maximum. So here from the equation 1, that is velocity is equal to a omega anta baratte. Yes, that is when we are substituting cos omega t is equal to 1, that is nothing but theta is equal to omega t, which is equal to 0. So you just remember here, when the velocity will be maximum in simple harmonic motion, at the mean position it will be maximum. At the mean position it will be maximum. Then the next one is acceleration in SHM. So what is this acceleration in SHM? Here in SHM, the acceleration is given by omega square into y, and it is not constant. It is not constant. So equations of translatory motion cannot be applied here. So namdu translatory motion ಏನು equations ಇದೆ ಅದನ್ನ ನಾವಿಲ್ಲಿ apply ಮಾಡಕ್ ಬರಲ್ಲ. So here acceleration for SHM is given by omega square into y, and this acceleration is maximum at extreme position. So students, 1 mark al baratte aita. So kinetic energy where it is maximum in simple harmonic motion, acceleration where it is maximum in simple harmonic motion. So kinetic energy is maximum, sorry, velocity is maximum at the mean position, and acceleration is maximum at the extreme position. Okay, then next here, the acceleration is minimum at the mean position. Acceleration is minimum at the mean position, right? So Abhishek, please mute yourself. Okay, then the next one, competitive study of displacement, velocity and acceleration. So here again some equations are there. So idella equations you just ನೆನಪಿಡಿ. Later they will give some expression, ಅದನ್ನ ನೀವು ಈ ಸ್ಟ್ಯಾಂಡರ್ಡ್ equation ಒಂದಿಗೆ equate ಮಾಡಿ values ಕಂಡುಹಿಡಿಯಬೇಕಾಗುತ್ತೆ. So ಇಲ್ಲಿ ನೋಡಿ, displacement is given by y is equal to a sin omega t, and velocity is given by a omega cos omega t, or we can also write it as it is a omega sin omega t plus pi by 2. Then the acceleration is given by minus a omega square sin omega t. So we can also write it as a omega square sin omega t plus pi. So idella standard equations ನೀವು theory ಕಲಿತಿರಬೇಕಾದ್ರೆ ಕಲ್ತಿರಬಹುದು ಇದೆಲ್ಲ ಹೇಗೆ ಬರುತ್ತೆ ಅಂತ. ಓಕೆ, ನಮಗೆ ಇಲ್ಲಿ ಬರೀ ಫಾರ್ಮುಲಾ ಅಷ್ಟೇ ಬೇಕು, ಆಯ್ತಾ? So already we have taken that is where it is maximum, where it is minimum. The velocity of the amplitude is omega times the displacement and amplitude. So here some points are there. You can just go through this. In SHM, the velocity is ahead of the displacement by a phase angle of pi by 2. In SHM, the acceleration is ahead of velocity by a phase angle of pi by 2. The acceleration is ahead of displacement by a phase angle of pi. Yes. So here you just remember these all points here. So namge ಕೆಲವೊಂದ್ಸಲಿ theory questions ಬಂದಾಗ ಇದೆಲ್ಲ ಕೇಳ್ತಾರೆ. Then what about the energy in case of simple harmonic motion? A particle executing simple harmonic motion, it possesses two types of energies. So what are the two types of energies here? That is potential energy and the kinetic energy. So what is the expression for potential energy? The potential energy in case of simple harmonic motion, it is given by half m omega square into y square. So we can also substitute the values here of y, that is a square sin square omega t. ಆಯ್ತಾ, ನಾವಿಲ್ಲಿ potential energy ಇದು ಎರಡು equation ಅನ್ನ ನೋಡ್ತಾ ಇದೀವಿ. So please note down these two equations. Later we can use it for the calculation part. Then where this potential energy is maximum, ನಾವೀಗ ನೋಡಿದ್ವಿ velocity ಮತ್ತೆ acceleration ಎಲ್ಲಿ maximum ಮತ್ತೆ minimum ಇರುತ್ತೆ ಅಂತ. Now the term is potential energy. So the potential energy is maximum and equal to total energy at extreme position. Extreme position alli maximum irutte. So that is U max is equal to half Ka square, that is nothing but half m omega square into a square. Yes. Then the next is kinetic energy. Here the potential energy is minimum at the mean position. It is maximum at the extreme position, minimum at the mean position, like the acceleration value. Next, kinetic energy. So kinetic energy ನೋಡಿ expression ಏನು ಬರುತ್ತೆ, ನಮಗೆ ಏನು ಗೊತ್ತಿದೆ, half mv square ಅಂತ ಗೊತ್ತಿದೆ, ಹೌದಾ? So here the kinetic energy is given by, we can substitute to the value of velocity. ನಾವು ಈಗಷ್ಟೇ velocity expression ಅನ್ನು ನೋಡಿದ್ವಿ, ಅದನ್ನ ನಾವು ಇಲ್ಲಿ substitute ಮಾಡಿದ್ರೆ ನಮಗೆ ಏನು ಬರುತ್ತೆ, m e square omega square cos square omega t ಅಂತ ಬರುತ್ತೆ. Aita. So m omega square, we can keep it and we can replace the terms and we can also write it as half m omega square a square minus y square. ಅಂದ್ರೆ ನಿಮ್ದು ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಯಾವ್ದಾವ್ ಫ್ಯಾಕ್ಟರ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿದೆ ಅಂತ ಕೂಡ ನೋಡಿ. ನೀವು ಯಾವ್ದಾದ್ರು ಒಂದು ಫಾರ್ಮುಲಾನ ನೋಡಿದ್ರೆ ಫಿಸಿಕ್ಸ್ ಅಲ್ಲಿ ನೀವು ಯಾವಾಗ್ಲೂ ಮತ್ತೊಂದು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಏನ್ ನೋಡ್ಬೇಕಾಗತ್ತೆ, ಅದು ಯಾವ ಫ್ಯಾಕ್ಟರ್ಸ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿದೆ ಅಂತ. ಸೊ ಇಲ್ಲಿ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಮಾಸ್ ಮೇಲೆ ಅಂತೂ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. ಒಮೆಗಾ ಆಂಗ್ಯುಲರ್ ಫ್ರೀಕ್ವೆನ್ಸಿ is amplitude, y is the displacement. So again, where it is maximum, where it is minimum. So the kinetic energy is maximum at the mean position and at the extreme position it is minimum. Okay. So once you learn the kinetic energy and the potential energy, now the turn is total energy. So total energy ನಾವು ಯಾವ ತರ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ, it is nothing but the sum of kinetic energy and the potential energy is called as what? Total energy. So this expression for total energy, we can substitute the value of kinetic energy as well as potential energy. ನೀವು ಇಲ್ಲಿ ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನ ಹಾಕಿದ್ರೆ ಇಲ್ಲಿ ನೋಡಬಹುದು ಈಕ್ವೇಶನ್ ಏನ್ ಬರುತ್ತೆ ಅಂತ. ಓಕೆ, ಸೊ ನಾವು ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ನಮಗೆ ಟೋಟಲ್ ಎನರ್ಜಿ ಒಂದು ಸ್ಮಾಲ್ ಈಕ್ವೇಶನ್ ಬರುತ್ತೆ, ದಟ್ ಇಸ್ 1/2 m omega square a square, m omega square a square. Okay, the total energy is not a position function, it is always remaining constant. Aita, yak constant ag uliyutte heli, that is whatever the potential energy is there, it gets converted in the form of kinetic energy. Kinetic energy idu potential energy agta irutte. So adukagi the total system, the energy is remaining constant anta navilli helabodu. Next, so energy position graph. So you can see this energy position graph. Already you know kinetic energy, all the expressions we have written. ನೀವು ಬರೀ ಇಲ್ಲಿ ಗ್ರಾಫ್ ಅನ್ನ ನೋಡಿಟ್ಕೊಳ್ಳಿ ಯಾವ ತರ ಬರುತ್ತೆ ಅಂತ. ಸೊ ಕೆಲವೊಂದ್ಸಲಿ ಅವ್ರು ಕೊಡ್ತಾರೆ 4 ಗ್ರಾಫ್ಸ್ ಕೊಡ್ತಾರೆ, ಅದರಲ್ಲಿ ಯಾವುದು ಕೈನೆಟಿಕ್ ಎನರ್ಜಿದು ಮತ್ತೆ ಪೊಟೆನ್ಶಿಯಲ್ ಎನರ್ಜಿದು ಪ್ರಾಪರ್ ರಿಪ್ರೆಸೆಂಟೇಷನ್ ಅಂತ ಕೇಳ್ತಾರೆ. ಯು ಕ್ಯಾನ್ ಸಿ ದಿಸ್ ಫಿಗರ್ ಹಿಯರ್. ನೀವು ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, ಇಫ್ ಯು ವಾಂಟ್ ಐ ವಿಲ್ ಎಕ್ಸ್ಟೆಂಡ್ ದಿಸ್ ಸೈಜ್ ಲಿಟಲ್, ಯು ಕ್ಯಾನ್ ಸಿ ದಿಸ್ ಕ್ಲಿಯರ್ಲಿ. ಆಯ್ತಾ, ಇಲ್ಲಿ ನೋಡಿ ಇದೇನ್ ಎನರ್ಜಿ y axis ಅಲ್ಲಿ ತಗೊಂತಾ ಇದೀವಿ, ಹೌದಾ? ಹಿಯರ್ ದ ಡಾಟೆಡ್ ಲೈನ್ ಅಪ್ವರ್ಡ್ ಏನ್ ಮೂವ್ಮೆಂಟ್ ಇದೆ ಅಥವಾ ಅಪ್ವರ್ಡ್ ಏನು ಕರ್ವ್ ಇದೆ, ಇದನ್ನ ನಾವು ಪೊಟೆನ್ಶಿಯಲ್ ಎನರ್ಜಿ ಅಂತ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಡೌನ್ವರ್ಡ್ ಏನ್ ಕರ್ವ್ ಅಂತ ತೋರಿಸ್ತಾ ಇದ್ದಾರೆ, ದಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಫಾರ್ ದಿ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ಎಸ್, ಸೊ 3 ಪಾಯಿಂಟ್ಸ್ ವಿ ಆರ್ ಟೇಕಿಂಗ್ ವೇರ್ y is equal to 0. y is equal to 0 ಅಂತಂದ್ರೆ ಇದು ಮೀನ್ ಪೊಸಿಷನ್ ಆಗುತ್ತೆ, ಸೆಂಟರ್ ಅದು. ಸೊ ರೈಟ್ ಸೈಡ್ ಇದು ಪ್ಲಸ್ a ಆಗುತ್ತೆ, ಲೆಫ್ಟ್ ಸೈಡ್ ಅದು ಮೈನಸ್ a ಅಂತ ಆಗುತ್ತೆ. That plus a minus a is nothing but what? It is the amplitude. It is the amplitude. Yes. Next we have, that is time period and frequency of SHM. So the time period expression is given by 2 pi by omega, or it can also be written as 2 pi under root of m by k. The frequency is nothing but it is the reciprocal of the time period. So frequency is nothing but it is the reciprocal of the time period. So here the time period actually ಬೇರೆ ಬೇರೆ equations ಅನ್ನ ಕೊಟ್ಟಿದ್ದಾರೆ in terms of inertia and spring factor. It is given. See, ನಮ್ಗೆ ಯಾವುದು ಕ್ವೆಶ್ಚನ್ ಬರುತ್ತೆ ನಾವು ಅದ್ರ ಮೇಲೆ ಫಾರ್ಮುಲಾನ ಯೂಸ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. So the basic expression is time period is 2 pi by omega. The time period is also given by 2 pi under root of inertia factor and the spring factor. Yes. Here we have the time period, that is 2 pi under root of m by k. Again ನಾವು ಇಲ್ಲಿ ಬೇರೆ 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 ತರ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾ ಹೋಗಿದೀವಿ ನೋಡಿ. m ಅಂದ್ರೆ ಮಾಸ್ ಆಗುತ್ತೆ, as it is we are keeping here. k ಅಂದ್ರು ಫೋರ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಯ್ತು. ಸೊ ನಾವು ಅದನ್ನ ಏನಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬಹುದು, ಫೋರ್ಸ್ ಬೈ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬಹುದು. ಸೊ ಅಗೇನ್ ದಿಸ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ we can substitute it as displacement divided by acceleration. ಇದೇನ್ ಮಾಡಿದ್ದಾರೆ, ಬೇರೆ ಬೇರೆ ತರ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾ ಹೋಗಿದ್ದಾರೆ, ಹೌದಾ? ಸೊ ನಾವು ಬೇರೆ ತರ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ the time period of SHM is given by t is equal to 2 pi under root of y by a. y ಅಂತ ಅಂದ್ರೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಆಗುತ್ತೆ, a ಅಂತ ಅಂದ್ರೆ acceleration ಅಂತ ಆಗುತ್ತೆ. ಓಕೆ, ಡೋಂಟ್ ಬಿ ಕನ್ಫ್ಯೂಸ್ಡ್ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್. ಕ್ಯಾಪಿಟಲ್ A ಅಲ್ಲಿ ಬಂದ್ರು ಅದು acceleration ಅಂತ, ಇದು ಸ್ಮಾಲ್ a ಬಂದ್ರೆ ಅದು ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಆಗುತ್ತೆ, ನೆನಪಿಟ್ಕೊಳ್ಳಿ. ಓಕೆ, the last concept, that is simple pendulum and the spring constant. So what is pendulum here? Simple pendulum is nothing but an ideal simple pendulum consists of a heavy point mass body suspended by a weight, inextensible and perfectly flexible string. from a rigid support about which it is free to oscillate. So ನಮಗೆ ಸಿಂಪಲ್ ಪೆಂಡ್ಯುಲಮ್ ಟೈಮ್ ಪೀರಿಯಡ್ ಮೇಲೆ ಕ್ವಶನ್ಸ್ ಬರುತ್ತೆ. ನಾವು ಇಲ್ಲಿ ನೋಡಬಹುದು ಟೈಮ್ ಪೀರಿಯಡ್ t is equal to 2 pi under root of L by G ಅಂತಂದ್ರೆ ನಿಮ್ದು ಟೈಮ್ ಪೀರಿಯಡ್ ಆಫ್ ದ ಸಿಂಪಲ್ ಪೆಂಡ್ಯುಲಮ್ is depending on acceleration due to gravity and it is depending on the length here. ಆಯ್ತಾ? Then the last is spring pendulum. So what is spring pendulum? Simple pendulum ಅಂತಂದ್ರೆ ಅಲ್ಲಿ pointless one bob ಇರುತ್ತೆ ಆಯ್ತಾ? So just one small point bob ಇರುತ್ತೆ, ಅದನ್ನ ನಾವು simple pendulum ಅಂತ ಹೇಳ್ತೀವಿ. What is the spring pendulum? You can see the figure. A point mass suspended from a massless string, ಅಂದ್ರೆ ಇದೇನ್ string ಇದೆ ಇಲ್ಲಿ, that is having very negligible mass, or placed on a frictionless horizontal plane attached with spring, constituting a linear harmonic spring pendulum. So here the time period of this is given by time period t is equal to 2 pi under root of m by k, or the frequency is reciprocal of that. Then here the time period of a spring pendulum is given by t is equal to 2 pi under root of m effective divided by k. K is spring constant. So what is m effective? M effective is nothing but m plus m by 3. ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ, mass m and mass small m is suspended from it. Its effective mass is given. You can see the effective mass. What is the expression? So this is the synopsis or the main points of the oscillation chapter. So the next we will proceed with the questions now. So let us see the questions. I'll share the PPT so that you can go through the questions. Yes. Okay, here is your first question. In damped oscillation, the direction of the restoring force and the resistive force. So there are two types of oscillations, that is damped oscillations and the undamped oscillations. Yes. So in the damped oscillations,
option B.
Option B, that is their opposite. Yes. So Kumar,
B, ma'am.
Padma. Yes, correct. So in the damped
Option B,
oscillations, here the restoring force and the resistive force are opposite to each other. Yes, very good. That is option B is correct. Then the next question is, the displacement y of a particle executing motion is given by y is equal to 4 cos square t by 2 into sin 1000 into t. This expression may be considered to be a result of superposition of the following number of harmonic motion. ಅಂತಂದ್ರೆ ಅವರು ಇಲ್ಲಿ ಒಂದು equation ಕೊಟ್ಟಿದ್ದಾರೆ, ಎದುರ್ದು, that is displacement equation is given. ಹೌದಾ? This expression may be considered to be a result of superposition of. So ಇದೇನಿದೆ, it is a resultant actually expression ಇದೆ. So ಈ expression ಬರ್ಬೇಕಾದ್ರೆ ಎಷ್ಟು waves ಅದರಲ್ಲಿ ಇದೆ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ ಅವರು. So it is a harmonic motion. So there, how many waves are there? They are asking here. So let us see the solution. Yes. Given equation that is y is equal to 4 cos square t by 2. ನಾವು ಇಲ್ಲಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಬೇಕಾಗುತ್ತೆ ಈ ಕ್ವೆಶ್ಚನ್ ಅನ್ನ. sin of 1000 into t. So 1000 into t. Yes. So here the equation ಇದೆಲ್ಲ ನಾನು ಇದನ್ನ ಸ್ವಲ್ಪ ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ಕೊತೀನಿ 2 into 2 ಅಂತ. So this everything is in a multiplication. So I can write it as 2 in a square bracket. So ನಾನು 2 into 2 ಅಂತ ಮಾಡ್ಕೊಂತಾ ಇದೀನಿ. 2 square t by 2 into sine of 1000 into t. Yes. So ಇದನ್ನ ಯಾಕೆ ಸ್ಪ್ಲಿಟ್ ಮಾಡಿದ್ವಿ ಅಂತಂದ್ರೆ ನಿಮ್ಗೆ ಈಗ ಅರ್ಥ ಆಗುತ್ತೆ. So here 2 again 2 ಏನಿದೆ ಅದನ್ನ ನಾನು as it ಇಡ್ತಾ ಇದ್ದೀನಿ ಆಯ್ತಾ. This one it as it. So inside this whatever you have, that is y is equal to 4 cos square t by 2 into sine of 1000 into t. So I'm putting this 4 2 into 2 anta, that is 2 into bracket 2 cos square t by 2 sine of 1000 into t. Yes. So here whatever 2 cos square t by 2 is there, the 2 cos square t by 2 according to your trigonometric identity I write it as cos of 2 cos square t by 2. Once again I'll cancel this step. So this I'll take it as cos t plus 1 or cos t plus 1 plus cos t. So how this will come, I'll explain you side. That is nothing but here you know that cos 2 theta is nothing but 2 cos square theta plus cos square theta minus 1, right? So according to this trigonometric identity, we can write it as cos t plus 1. We can write it as cos t plus 1. So let us simplify the further steps. So here whatever 2 is there, now I'll multiply inside the bracket. Therefore we are going to get it as 2 cos t into sine 1000 into t, then plus 2 sine 1000 into t. Yes. Istu step artha aita ellarigu? Is it clear to everyone?
No.
Is it clear, students?
Ma'am. Ma'am, ಇನ್ನೊಂದು repeat ಮಾಡಿ.
Okay, once again I'll explain this. That is, the given equation is y is equal to 4 cos square t by 2 into sine 1000 into t. So this 4 I am splitting it as 2 into 2. Therefore 2 is common. Inside the bracket we have 2 cos square t by 2 into sine 1000 into t. So this is at least given. Idu question alle ಕೊಟ್ಟಿರೋದನ್ನ ನಾವು rearrange ಮಾಡಿ ಬರ್ದಿದ್ದೀವಿ ಆಯ್ತಾ. So ಇಲ್ಲೇನ್ 2 cos square t by 2 ಅಂತ ಇದೆ. According to your trigonometric identity of cos 2 theta na nanu 2 cos square theta plus 1 anta ಹೇಳ್ತೀವಿ minus 1. So it is minus 1. Yes. Here for half angle, ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನಮಗೆ t by 2 ಇದೆ, theta by 2 ಅಂತ ಆಗುತ್ತೆ. So for half angle if you apply the formula, here this becomes, it is nothing but cos theta is equal to, it is nothing but cos theta is equal to 2 cos square theta by 2 minus 1. Therefore, cos theta plus 1 is equal to 2 cos theta by 2. Namge theta idalli illi question alli t anta ide. So here you can see this 2 cos theta by 2 can be written as it is cos theta plus 1. So according to that, we have simplified this one. Later, I am just multiplying 2 inside the bracket. Later, I am multiplying 2 inside the bracket. So now we can apply, that is cos A into sin B formula. So cos A into sin B formula, if I apply here, it is nothing but sin A plus B plus sin A minus B. Yes. I hope you know that formula also. So according to that, I'll apply that and I'll write the solution. That is, it is nothing but sin A plus B. A ಅಂತಂದ್ರೆ ಎಷ್ಟಿರುತ್ತೆ ಇದು t ಅಂತ ಆಯ್ತು. B ಅಂತಂದ್ರೆ ಎಷ್ಟಿದೆ ಇದು 1000 t ಅಂತ ಆಯ್ತು. So it is nothing but what 1001 into t. Yes. Next. Plus A minus B. So A minus B again. So A minus B is nothing but what sin of 99 into t plus 2 sin 1000 into t. Yes. So here you can see this to get this equation. Which equation? Our Kotiro equation 4 cos square t by 2 into sin 1000 into t. To get this equation, how many sine functions we are getting here? That is 1, 2 and 3. Therefore, the following harmonic, that is to get the equation, the superposition of 3 waves or the 3 harmonic motion is required. So answer is 3 here. So given equation, we are using 2 mathematical steps. That is, one is cos 2 theta formula and one more we are using cos A into sin B formula. Is it clear, students?
Yes,
As we are getting, yes, okay. So I'll go to the next question now. As we are getting the 3 equations in terms of sign, it means that the given question is consisting of 3 equations to get the resultant. That is 999. Okay, it is not 99, it is 999. So let us go for the next question. Spring is pulled down by 2 centimeter. What is amplitude of motion? So here the spring is pulled by 2 centimeter. What is the amplitude of motion? Can you answer this? Yes. So directly also we can answer here, when whatever the spring is there, that spring, whatever the length is there, if you are pulling it by 2 centimeter. Option?
Option A. A.
Option C. Yes, Lohit, that is correct. It is option C, 2 centimeter. Yakantandre. So how much you are pulling? So the same amplitude it will change. The same amplitude it will change. Okay. Right. So that is nothing but 2 centimeter itself. That is nothing but 2 centimeter itself. Yes. Option C is the correct option. Yes, Rakshita. Correct. So next question. Two clocks on Earth is controlled by a pendulum. It is controlled by a pendulum. The other by a spring and other by a spring. If both the clocks are taken to the moon, then which clock will have the same time period of the Earth? So you have 2 clocks here. One is a pendulum clock and one is a spring clock. Okay. So if both the clocks are taken to the moon, so now we consider we need to consider the factor first one time that is of the spring and of the simple pendulum time period. Adu gottiddaga moon mele enagutte, whatever the acceleration due to gravity is there, as we know that now illi kaltidivi school level alli kaltidivi, what is that? The acceleration due to gravity on the Earth, suppose if it is g, on the surface of the moon, it is 1/6 of the value of the G. It is 1/6 of the value of the G here. ಹೌದಾ ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ಲೆಸ್ ಆಗತ್ತೆ, ರಿಡಕ್ಷನ್ ಆಗತ್ತೆ. So what is your equation of time period here? The time period equation for simple pendulum, it is 2 pi under root of L by G. ಅಂತಂದ್ರೆ ಇಲ್ಲಿ acceleration due to gravity ಮೇಲೆ ಇದು ಡಿಪೆಂಡ್ ಆಗಿದೆ ಅಂತ. Yes, very good. So but spring clock ಏನಿದೆ, spring clock the time period, it is not depending on the acceleration due to gravity value. It is independent of that. Therefore here the time period which will remain same, that is for the spring clock, that is for the spring clock. Why? Because it does not depend on the acceleration due to gravity. So whether you take it to moon or any other planet, the value will not change for the spring clock. Okay, so who all have given the answer? That is Chandru, Rakshita. Yes, is it clear, students? That is spring clock is having the same time period. Why? Because it is not depending on the acceleration due to gravity. But for the simple pendulum, yes, it is depending on the acceleration due to gravity. Then the next question is, when a particle performing uniform circular motion of radius 10 centimeter, it undergoes the SHM. Are simple harmonic motion exhibit ಮಾಡ್ತಾ ಇದೆ ಆಯ್ತಾ. So Abhishek is giving the answer as 10 centimeter. What will be its amplitude? What will be its amplitude? So options they have given is, that is 10 centimeter, 5 centimeter, 2.5 centimeter, 20 centimeter. So maximum all the students are telling it as 10 centimeter. So nimge amplitude andre gottirbeku, then you can answer this question. Here when the body is performing simple harmonic motion, howda, what is the amplitude here? Amplitude is the maximum displacement. Yes, it is Chandru, Rukmini. Yes, it is option B correct agide. Option B is correct here. Yes, Kumar. Yakanta andre illi nodi, what is your amplitude? Amplitude is nothing but what? Maximum displacement of the particle from the mean position. Antandre ishte baratte adu. Hauda? So this is nothing but you can consider, if you assume it as a circular motion, this is nothing but the radius here. So the radius itself, it is equal to what? It is equal to the amplitude. It is equal to the amplitude. So sorry, that is 10 centimeter only. It is not, I thought it is 5 centimeter it is given. Yes, it is 10 centimeter. Sorry, it is my mistake. Radius is given as 10 centimeter. I thought it is 5 centimeter given. It is 10 centimeter. Option A. Who all have given the option A? That is right. Sorry. Yes. Amplitude and the radius are equal in this given case. Therefore, it is 10 centimeter itself. Okay, students, the next question. For a magnet of time period capital T, magnetic moment is capital M. If the magnetic moment becomes 1/4 of its initial value, 1/4 of its initial value, then the time period of oscillation becomes, options are half of initial value, 1/4 of initial value, double of initial value, 4 times the initial value. Half, some are saying A, some are saying B. Yes. So nimge ee tara questions ಜಾಸ್ತಿ ಬರುತ್ತೆ ಆಯ್ತಾ. ನಿಮಗೆ ಯಾವಾಗೂ equations ಏನಿದೆ, you should be perfect for the equations what they are giving you. The time period of oscillation T is equal to, it is 2 pi under root of, it is I divided by MB. What is I here? Moment of inertia. I ಅನ್ನೋದೇನಿದೆ, moment of inertia ಇದೆ. M is mass, B is magnetic field. So ಇಲ್ಲಿ ನಿಮಗೆ ಕ್ವಶನ್ ಅಲ್ಲಿ ಏನಂತ ಹೇಳ್ತಿದ್ದಾರೆ ಅವರು, in the question they are giving you as, in the question they are giving you as they are giving you magnetic moment. It is given as magnetic moment. So sometimes they may ask you about the mass. If the value is increasing, what happens to the time period? Or if the magnetic field is increasing or decreasing, what happens to the time period? Here they are asking you about the magnetic moment. Yes. What is the answer? Here I is moment of inertia. You can substitute it as m r square also. Okay. Next, m is mass. Illi m mass ide. Idu magnetic moment alla, idu mass aita. Idu magnetic field anta barutte. What they are giving you in the question, the magnetic moment is becoming 1/4. So if the magnetic moment is becoming 1/4, whatever the time period is there, it is becoming twice. It is becoming twice, means double the initial value. It is option C. It is option C. Yes, it is option C. It is not option B. It is option C. If that is becoming 1/4, here it is increasing by 2 times. Option C is correct. So sometimes instead of magnetic moment, they may ask you about mass also. Illi mass enadru 1/4 ಆಗ್ತಾ ಇದೆ ಅಥವಾ mass enadru double ಆಗ್ತಾ ಇದ್ರೆ what happens to your time period? ಆ ತರನು questions ಬರುತ್ತೆ. So ನೀವು ಒಂದು question ನೋಡ್ಬೇಕಾದ್ರೆ ಬೇರೆ angle ಅಲ್ಲಿ think ಮಾಡಿ ಆಯ್ತಾ. So here when the magnetic moment is becoming 1/4 of the initial value, your time period is increasing by twice. Option C. Next question. The next question is time period of simple pendulum of length L and a place where acceleration due to gravity is G is T. What is the period of a simple pendulum of the same length at a place where the acceleration due to gravity is 1.029 is? So here we need to use the time period equation for the simple pendulum. So what is the change here? That is when the acceleration due to gravity is G, the time period is T. When the acceleration due to gravity is changing to 1.029, then what happens to the time period? That we need to check out. So let us solve this. It is given by the time period T is equal to 2 pi under root of L by G. Idu namdu first equation. Hauda? So here what is happening? The length is same only. The length is same only, and but acceleration due to gravity is changing to what it is 1.029 into G. Yes, the new time period equation I'll write. That is T dash is equal to 2 pi under root of L by G dash. Yes. So I can substitute the value of G dash here. What is the value of G dash? It is 2 pi under root of L divided by 1.02 into G. Yes. It is G. Okay. It is not 9. It is G. It should be G. Now take the ratio of this T dash by T. So let us take the ratio of T dash divided by T. So if I take the ratio of T dash by T, 2 pi cancel agutte, L kuda cancel agutte. So we are left with what? We are left with only that is G divided by 1.02 into G. So here this G will also get cancelled. G kuda cancel agutte. Now idanna yav riti baribodu? 1 divided by 1.02. We can also write it as 100 divided by 102. So what is 100 divided by 102? So what is the answer? Further one step within you calculate ಮಾಡಿ answer ಕೊಡಿ ಏನು ಬರುತ್ತೆ? It is option B or option C? Under root of 100 divided by 102. So your new time period will be, yes, Chandru, correct. That is 0.99. It is 0.99 T. Option C is correct here. Option C is correct. Okay. So let us go for the next question. Yes, the next question is, in the case of forced oscillations, so as I told you, damped oscillations, forced oscillations. Here it is forced oscillations now. Which of the following statement is not true? That is, frequency equals that of extreme external periodic force. Option B, amplitude depends upon the damping coefficient. Option C, amplitude tends to infinity at resonance. Higher the damped coefficient, lower is the amplitude at resonance. So which is true for forced oscillations? Which is not true, which is not true for the forced oscillations? Yes, students, what is the answer? See, yes, correct. That is, amplitude tends to infinity at resonance. So it is never possible. So this is not true. It is correct. Yes, very good. Okay. Then the next question. The motion of a particle executing SHM, simple harmonic motion, is given by x is equal to 0.01 sine of 100 p into bracket t plus 0.05, where x is in meter and t is in second. The time period in second is. So simple question, we need to just compare it with the standard equation of simple harmonic motion. So ಕೊಟ್ಟಿರೋ function ಏನಿದೆ, that is nothing but x is equal to 0.01 sine 100 into p into bracket t plus 0.05. Yes.
Option B. Option B.
Option B. Everybody is getting the answer? Yes, it is option B. Option B is correct. So whoever don't know, just I'll write the hint so that later you can continue with the question. That is, x is equal to, the standard equation is a sine omega t. It is a sine omega t. Okay, so if we compare here the time period they are asking. So here by comparison, you can see this is the amplitude value, that is 0.01 is your amplitude. And here omega is equal to, it is 100 into pi. It is 100 into pi. This is not p, it should be pi here. It should be pi here. Okay, therefore we know that time period t is equal to 2 pi divided by omega. So substitute here, that is 2 pi divided by omega is 100 into pi. So pi will get cancelled. This is nothing but 0.02. It is 0.02. So option B is correct. Yes. Yes, Chandru, Kumar, Rukmini. Yes, very good. So last one more question we will discuss. In damped oscillation, the angular frequency of the oscillator. So in case of damped oscillator, what happens to the angular frequency? Keeps on decreasing, keeps on increasing, remains the same, and it fluctuates. Which option is right? Yes. A, B, C, D. C.
Option A.
So here, that is, it remains the same. It remains the same. That is the correct option here. Okay, it remains same. Not, it is not keep on decreasing. So option C is correct here. So next question I'll display. You just see that you can do it as a homework. Otherwise, you can tell this. This is also direct question, so you can tell this one, that is the acceleration of particle executing SHM when it is at the mean position. So when it is at the mean position, it is infinite, varies, maximum 0. So in the theory part, we have discussed this one. It
0,
is-
ma'am.
Yes, it is 0. Yes, very good. It is 0. And I think this is also a direct question. So this also you can answer. In SHM, graph of which of the following is a straight line? Total energy against displacement, potential energy against displacement, acceleration against time, velocity against displacement. So this is also a direct question. So in the simple harmonic motion, which of the following graph is a straight line? Yes. A, that is total energy against displacement. Yes, that is right. Other students? C, acceleration. What about others? Yes, it is A. It is A, that is total energy against displacement, that is a straight line. Okay. So some more questions. Tomorrow we will continue, students. Okay. Thank you.
Thank you, ma'am.